Hello everyone, my name is Bethany Thompson, starting us off with the project SpotiScry. This team project is all about the science behind hip-hop music. We wanted to find out what makes a song on Spotify a top hit, while others are left in the dust. We are the SpotiScryers, a team of data scientists, and this project is a culmination of what we've learned during our time at Codeup. Our team consists of myself, Matthew Mays, Kwame Taylor, and Brandon Martinez. Today, I'll be going over the highlights of SpotiScry with the executive summary. Next, Matthew will describe the process we obtained and prepared the data. Then, Kwame will go over key exploration insights and recommendations. Finally, Brandon will explain our machine learning model before we tie it all together with our final conclusions. So the music industry is a big business for artists and anyone else in this creative process. Of course, with the possibility of earning big bucks comes an equal risk as well. Because it can cost thousands of dollars, if not more, to create a song, it can be devastating to release music that isn't successful. The process isn't easy either, to go from songwriting to marketing to the final release day and everything else in between. The solution to this big risk? Use the trends backed by science to get those streams rising. And our goal is to identify these trends. What causes a hip-hop song on Spotify to gain users' attention and keep it? We found these trends to include making the song explicit, having a high danceability, and featuring one or more artists. We have additional insights as well, so stick around to hear more about what makes a song on Spotify hit or miss. Now, Matthew will take it over with the process for transforming the information from Spotify to a data frame ready for exploration and modeling.
Thanks, Bethany. As for the data process we performed for this project, our first step was to get our hands on some data we could work with. Once we had the data, we moved it into Prepare, where it gets nice and neat to make exploration easier. After preparations were done, we were able to begin exploring. Often while exploring, we would see features we could make or changes to the dataset would become necessary. This would be our pre-processing phase, and we routinely went between exploration and pre-processing before we were finally ready for modeling. So, let's take a deeper dive into what each of those stages looked like, starting with acquisition. Now, as for actually acquiring the data, it was pretty straightforward. Spotify has its own public API that contains tons of data from a huge portion of their media selections. We compiled a playlist of over 6,000 hip-hop songs from many different artists, subgenres, and time periods. Then we used Python with a Spotify library to connect to their API in order to pull out some very interesting features that Spotify keeps track of for each song. These range from info on the track itself, the audio characteristics, or info on the album. All of this collected data was stored in a data frame for later use using the Pandas library. Now that we had the data, we started preparing the data for exploration. So, what makes data messy? We searched through our dataset and tried to find things like missing values, incorrect data types, and any outliers or anomalies that may have been an issue. We did our best to correct any issues that could be corrected and dropped a few that couldn't. After we cleaned the data, we thought about what would be necessary for our exploration and modeling. Through the use of the scikit-learn library, we had a lot of utility in creating new features, adjusting measurements to be more easily understood, and also following good data science practices like splitting our data into train, validate, and test sets, as well as creating scaled copies for modeling. There was one important thing we kept in mind throughout this process: our target variable, popularity. So, what does it mean that our target variable is popularity, you may be asking? Well, for this case, we use Spotify's popularity rating, which calculates a number between 0 and 100 that it gives to each track. This is calculated based on the total number of times the track has been played, weighed against how recent those plays were. This means that a moderate song that came out this year may have a higher popularity rating than some older songs that did well but have been around for a while. We found 4 distinct groups that the popularity trended towards. Most of the data fit into 2 groups: the low and moderately popular songs, ranging from 10 to 40 and 40 to 70 respectively. There was also a large group of very low popularity songs, which all had popularities of 10 or below. The last was all of the hits, or the songs with high popularities of 70 plus. Next up, Kwame will be able to give you a look into our project from the perspective of someone with domain experience, as well as guide you through our exploration.
Thank you, Matt. Next, I'll discuss the exploratory data analysis of our data, paired with my domain knowledge as a hip-hop artist and producer myself. Some of the top drivers of song popularity in this dataset are when there are featured artists on a track, when there is a low lyric-to-music ratio, and when there is high danceability as calculated by Spotify's API. On the y-axis, we have popularity from 0 to 50. On the x-axis for featured artists, we counted songs with no featured artists and then songs with one featured artist or more. On the second and third plots, the x-axis is bended to low, medium, and high. There were many more songs without featured artists than with, and songs that featured artists other than the primary artist on a track did much better than songs without. It also seems that people are more willing to listen to longer songs if they include featured artists. A low lyric-to-music ratio, or speechiness as Spotify's API calls it, was more popular, and most songs fell into the low range. As for danceability, it is valued between 0 and 100, and most songs were in the mid-range. Songs with high danceability were much more popular than songs with low danceability. Each track is also assigned around 3 to 7 genres. Some are umbrella genres, such as rap, hip-hop, and pop rap, and some are subgenres, like gangster rap, escape room, and dirty south. In our data, there are 386 possible genre labels. In this bar plot, we visualize the average popularity of songs belonging to a genre, focusing on subgenres with high average popularity and at least 150 total tracks. The winner, with 189 tracks and an average song popularity of 58, is melodic rap, represented here by artist Lil Uzi Vert, who has 34 melodic rap tracks to his name. From left to right, there's an extension representing emo rap, Lady representing vapor trap, Nicki Minaj for post-teen pop, Ludacris for trap, Megan Thee Stallion for Houston rap, Lil Jon, the king of crunk, and Lil Nas X, a quintessential artist of 2019 for his hit Old Town Road, representing LGBTQ+ hip-hop. Next, I'll demonstrate how musical composition, such as tempo and key signature, can be a valuable tool to influence a song's success, whether you are an artist, producer, or executive. In our exploratory data analysis, we found that what makes a song popular compositionally is different from hip-hop subgenre to subgenre. Since SpotiScry is based in Texas, I'll demonstrate our findings on Southern hip-hop, which includes Houston hip-hop, Atlanta hip-hop, and Dirty South rap. In this stacked bar plot, we visualize the number of songs in each category of popularity and tempo. Tempos 111 to 130 and 131 to 150 both have similar amounts of high popularity songs, but 131 to 150 has many more moderate popularity songs. It should also be noted that most songs in Southern hip-hop were 90 beats per minute and under, which is pretty slow. Songs with tempo under 90 beats per minute have lower but somewhat comparable numbers of high and moderate popularity songs. However, this range has more low and very low popularity songs than the other tempo ranges. So while you can certainly have a hit slow Southern hip-hop song, it may be easier to gain popularity on a faster song. Perhaps this is because pop songs, on average, are 116 beats per minute, and slower tempo songs are more often played in Southern dance clubs, and not as much in other regions, reducing a song's ability to spread geographically. On this slide, we visualize the number of songs with high popularity, and each category of key and mode. These two features combined is what is known as a key signature. For example, C major is one of the most common key signatures used in Western music. It has no sharps and no flats. Songs in a minor key only have 1.2 points lower popularity on average than songs in a major key. However, songs in a minor key are less common, so there could be less competition for a song there. The most common key signatures in high popularity Southern hip hop are B flat minor, C sharp major, and D major. In summation, the musical composition elements I'd recommend to artists and producers who are looking to make a Southern hip hop hit are 131 to 150 beats per minute tempo, B flat minor key signature, and a 4/4 time signature. Now I'll turn it over to my colleague Brandon to talk about our model performance.
Thanks, Kwame. Our modeling process consisted of using regression analysis and feature engineering to justify the relationships between song popularity and those key features that have the most influence. In many cases, ideal variable relationships aren't always linear. We identified that a simple linear model was underfit, meaning it was unable to capture all the patterns in our data. We also wanted to be sure not to overfit by using a more complex model. Finally, we settled on a second-degree polynomial regression model that allowed it to perform well on new and unseen tracks. So why is this model relevant? Our model allowed us to determine statistical significance between song popularity and key features. This model was also able to make predictions, with the smallest margin of error calculated based on how far off the actual values are from the predicted values. The polynomial regression model is actually a combination of the polynomial features algorithm and simple linear regression. Polynomial features create new variables from the existing ones. Let's take two features like danceability and energy for example. Using a degree of 2, the algorithm will square each feature, take the combinations of them, and use the results as new features. This allows the regression model to make better connections with relationships that may not be linear or a one-to-one correlation. The polynomial features algorithm was a great tool for making connections under the hood and giving our analysis more insights to work with. Here we can see the top 10 drivers that are model ranked by their feature coefficients. As you can see, some of the features are actually combinations or the squared versions of themselves. However, not all features are created equally. Our machine learning model indicated that features like energy incite a larger increase in popularity, while exclusively speech-like tracks seem to degrade it. Now that we know that these features and their combinations are significant for determining popularity, how can we apply this to the industry? Music producers and artists can now use our model and utilize these key combinations to boost the potential to make hit songs. I will now allow Bethany to wrap it up with conclusions and takeaways.
Thanks, Brandon. So after acquiring data from hip-hop songs throughout the 80s to today, we found what features were drivers of popularity, such as a song being explicit and having featured artists. We also found that subgenres could have different drivers specific to that style of music. While our modeling phase utilized different combinations of algorithms and features, the best performing model was the additional insight into what features were key drivers. And the model with the best performance was a second-degree polynomial using 7 features from the data. We highlighted the top 5 drivers, including the 5 biggest drawbacks from the results of feature engineering. This model was able to predict popularity 6% better than the baseline that just predicted the average popularity for any given song. Now this isn't the end of SpotiScry. We still want to learn more from this project by adding more songs from hip-hop and additional genres of music as well. How do these key drivers change when the music is rock or pop? Will different models perform better for different genres? We also want to incorporate time into the data to discover how long songs stay a hit before becoming forgotten. Or better yet, discover what creates a timeless classic. To end, we want to thank you all for your time today. To explore more of our analysis, check out our project from our GitHub repository here or our Codeup alumni pages. Thank you and goodbye.